Hello, my name is Matt Blevins, and I'm a math teacher in residence at NumWorks. Today, we are going to explore how to best use NumWorks to succeed on the Algebra 1 Regents examination. First, let's familiarize ourselves with the keyboard, which is arranged in 3 different zones. At the bottom, we have our number pad and basic operations like addition and subtraction. In the bottom right corner is EXE, which stands for execute, and the answer button, which reuses the previous answer. Something you might notice is that there is no separate negative key. Instead, the minus key works as both subtraction and indicating a negative value, with no need for syntax errors. In the middle, we have our advanced functions, which include commonly used operations and values, including trig functions, logarithms, square root, and pi. On the next row up, there are other useful buttons as well. Shift is used for all the yellow options. For example, Shift pi will give you the equal sign. Alpha is used to write any of the alphabetical characters. For example, Alpha 3 will give you the letter Y. Pressing the alpha button twice will enable an alpha lock if you want to type more than one letter at a time. The XNT button is a shortcut for those variables along with theta. Press once for x, a second time for n, a third time for t, and a fourth time for theta. Pressing it again will recycle through those variables in that order. The variable key is where you can access stored variables or use it as a way to quickly store a solution. The toolbox key is a very important button that we will use quite frequently to access additional functions. Think of it like your menu button. Next, we also have the delete key. At the very top, we have the navigation zone, allowing us to select apps and options, a back arrow to return to the main screen and back out of menus, and an OK button that works just like the execute button and can be used to confirm selections.
When you turn on the calculator, the first difference you might notice between NumWorks and other devices is our app-based design. We recognize that the students in today's classrooms are from a technological world. Technology is used in all other aspects of their lives. However, often there is a divide between their real world and the math world. Outdated technology only makes the divide wider. By integrating devices that students are used to, students learn how to use the calculator quickly and feel they can engage in the mathematics. If you have a calculator with you, I encourage you to follow along. If you don't, you can use the free online emulator that is available directly from the NumWorks website, or you can be like me and download the free app on your smartphone or iPad from your app store. These can be accessed by anyone for free without login or registration. Together, we will examine how NumWorks can benefit students taking the Regents Exam for Algebra 1. I'll be using the release questions from the January 2025 Regents Examination along with the NumWorks app. The first set of problems that we will look at together can be done on the calculation application. Our first problem is a geometric sequence. Let's recall that a geometric sequence means that we are multiplying by the same number to get to the next term. Because NumWorks uses typical math notation, fractions are much simpler to work with. If I type 1/2 times 1/4, I can easily make sure that I'm typing the problem correctly, and my result is even in fraction and decimal form without any additional steps. While this is not the correct answer, we can continue working through multiplying 1/2 by the other choices to see that 4 is the correct answer. Next, let's see how NumWorks can help us with radicals. What is the sum of 8 times the square root of 3 and the square root of 3? Since sum means to do addition, we can add these two values together, and NumWorks provides the simplest radical form automatically. These exact solutions will always be provided on the calculation application. We can see that answer 4 is the correct answer here. The next set of problems that we will look at together can be done on the Grapher application. This application is also useful for several free response questions we will look at later. To return to the app screen, use the Home button. Then we can navigate over to Grapher and click OK. On this problem, we want to see when the expression x cubed minus 36x is equivalent to one of the solutions provided. To compare which expressions are equivalent, we can compare their graphs. Equivalent expressions should have the same graph if we set them equal to y. Let's input the first expression, x cubed minus 36x. Press OK on Add an Element to begin typing. Note that you can use the XNT key to input the variable x. After typing the expression, press OK. NumWorks will automatically add y equals since it is a single variable expression. Let's also type in answer 1 to see if they have the same graph. Once you've typed everything in, navigate down to Plot Graph and press OK. Notice that we have two distinct graphs, so these equations are not equivalent. Let's return to the Expressions tab and try this again with answer 3. Delete answer 1's equation and add in the expression for answer 3. Notice that there are no differences between these two equations. It looks like one graph. This is our correct answer, and it is made possible because of our automatic zoom feature. On other calculators that use a default window, you might have a graph that is not visible, but with NumWorks, the auto zoom is going to make sure that both graphs are visible if there are two different graphs. For our next problem, let's delete the prior equations. We want to find the ordered pair that is a solution to the given equation. Type in the equation and select Plot Graph. When viewing a graph, NumWorks makes it easy to find a specific point. If you type in a number and press OK, the calculator will find a point with that x value. Note that if you are typing in a negative number, you would want to type the number first, then add the negative symbol to the beginning because the minus key also acts as a quick zoom out button. Typing 0.75 gives us a y value of 3. So that is not the correct answer. Try typing in 1.25 and see that the y value given is 4. That is the correct answer for the problem. We could check the other solutions as well just to be sure. Our next problem is very similar in terms of our approach. We want to find the equation that passes through the points -1, 8 and 4, -2. We simply have 2 points we must check instead of 1. Let's type the first equation in and choose Plot Graph. Since these are solved for y, we can save a little time by just typing the right side of the equation. To type in -1, we must first type 1 and then arrow left to be in front of 1 and then add our negative sign. Alternatively, we could press OK and then type in -1 right here for the x value and press OK. Notice that we are given the point -1, 8. So far, so good. Let's type 4 and hit OK, and we'll see that we are given 4, -2 as a point on the line. Answer 1 is the correct answer. Feel free to repeat this with the other equations to see that they are incorrect. The next problem that we will look at together can be done on the equations application. This application can also help students get partial credit on several free response questions we will look at later. For this problem, we want to solve the equation -2 times the quantity 3x minus 5 equals 9/2 x minus 2. We can navigate to the Equations app and type in this equation. Note that you must select an empty template to begin typing. Note that you do not have to press anything to add an equation. You can simply start typing. Navigate to Solve the Equation and click OK to see the result as both a fraction and a decimal. The equation application can solve many different types of single variable equations. And it looks like our answer is 8/7. The next set of problems that we will look at together can be done on the statistics and regression applications. The important difference here is that statistics deals with one variable stats, while regression will allow us to work with two variable statistics. Here we have a list of data for the highest August temperatures for several years in one town. We can input this temperature data into the statistics application to work with it. On the statistics application, let's enter each temperature. Note that it will automatically add a frequency of 1. While none of these numbers repeat, you could choose to simply type it again or change the frequency to 2 if one of them did, whichever one you prefer. To view the interquartile range, or IQR, we can then navigate to the Stats tab at the top. Notice that you can see both the phrase interquartile range as well as the abbreviation IQR. This vocabulary reinforcement is very helpful on the NumWorks graphing calculator. Scroll down to IQR to see that it has a value of 11, which is answer 3. For our next problem, we have a list of inputs and outputs of a function given in a table. Since we have an x and f of x, we can use the regression application to visualize this data. Let's type these points in the regression application and then navigate to the Graph tab to see the scatter plot. Just like in the grapher, we will auto-zoom to show all of the points. If we know the shape of our answer choices, this may be all that we needed to answer the question. For more detail, we can also use the toolbox key to add the function shapes as a regression model. If we add a linear model, we can see that it is not a straight line, so this is probably not our answer. Press the toolbox key again to select a new model. Quadratic is our next answer choice, so let's select that one. Notice that this one looks better than the linear model, but still doesn't match the points exactly. If we click the toolbox key again, we will see a value for r squared. We should take note of this number to see if we find a different model with a higher r squared value. Let's select the next model type, which is exponential. Scroll down to find it. Notice that it looks like the exponential model gives us a graph that is exactly on each point. Using the toolbox key, we can see that our r squared is 1, which means that this is a perfect model for the data points, and this makes this the best answer. For our final regression equation, we are given the average heart rate, x, and calories burned, y, for 7 men on an Olympic rowing team during a 1-hour workout class. Let's go back to the Data tab to input this information. Using the Delete key on the column heading will delete the entire column. This can be a quicker way to clear out a large data set. After typing in all of the data, let's go back to the Graph tab. We are told to write a linear regression equation. So let's add the linear regression model to this scatter plot. Once you've added the regression model, you can see the regression equation by navigating down to the regression model or by clicking the toolbox key again. Here we can see our values, but remember that we need to round to the nearest tenth. This makes our answer y equals 9.1x minus 527.6 for the first part of our question. Next, we are asked to state the correlation coefficient. While this is indicated on this page with the letter R, we can also head over to the Stats tab to see this written out in word form if we don't remember if it is R or R squared. Rounding gives us a correlation coefficient of 0.9. Since this value is very close to 1, this means we have a strong positive correlation. Keep in mind that a correlation of negative 0.9 would still be strong, but it would be a negative correlation. While this is technically a free response question, NumWorks makes it very easy to get full credit for these questions because of how intuitive the device is. Let's take a look at some more free response questions. While NumWorks cannot show students the work required for full credit, it can be helpful for students to at least have the correct solution for partial credit in addition to knowing the answer they should be working toward. For instance, this problem asks us to rationalize the denominator. We are given the expression 4 divided by the square root of 2. Let's return to the calculation application and type this in. Typing this in gives us a solution of 2 times the square root of 2, because NumWorks will simplify anything with a radical. Now that we know the correct answer, let's see if we can figure out how to get there. Since we are dividing by a radical, We can multiply by that same radical in the numerator and denominator. This gives us 4 times the square root of 2 in the numerator, and the square root of 2 times the square root of 2 is simply 2. Notice that I typed that in on the NumWorks calculator to get that simplest form there. From here, I could divide 4 divided by 2 to get to my final answer of 2 square root 2. For the next question, we are asked to graph the function f of x equals x squared plus 4x plus 3. While we have to draw this out, the grapher application can help us get some points to use. Note that you can even use a template to select the function notation to match what is used in this problem. Navigate over to Templates and press OK, and we have a function template over here that we can select. Let's finish filling out the equation and press OK. While we could look at it visually, the table will give us some points to plot. Select Display Values to see the table. NumWorks defaults to 0 through 10 for the table, but we can easily change this to make it -5 to 5, since this is the grid that we are given for this problem. Select Set the Interval and change the values to start and end at -5 and +5, respectively. Keeping a step of 1 makes it easy to graph the points we choose because we will count by 1. Note that we might not be able to use all of these points, but looking at the table, we can see that we do have some points that we can graph: -4, 3, -3, 0, -2, -1, -1, 0, and 0, 3. We could then plot these points and connect them to form our parabola. Don't forget to put those arrows at the end. For the second part of the problem, the axis of symmetry can be found by finding the vertex. This can be seen visually by going to the Graph tab and finding the point labeled minimum or maximum depending on the direction of the parabola. In this case, it is a minimum. NumWorks shows interest points like the minimum values. Since this would be a vertical line to make the axis of symmetry, we would use x equals -2 for this problem. Note that I had to turn the auto zoom back on to see this view more clearly. I could even make sure that I have this right by typing in x equals -2 as another element in my grapher application. You are not limited to y equals when working with NumWorks. Note that my new line goes right through the center of my parabola. Here we have another function, f of x equals the quantity -3x minus 5 divided by 2. And we want to determine the value of x when f of x is -22. Let's use the Equations app by replacing f of x with the value -22. After typing in our equation, we can select Solve the equation at the bottom to see that x is 13 when f of x is -22. While this does not show us the work algebraically, we can earn some credit for having the correct answer, and having this answer may help us recognize if we make a mistake when solving this equation. Let's examine the steps to solve this equation algebraically. Since the right side of the equation is all being divided by 2, we could multiply by 2 to cancel out this fraction. Make sure to do this to both sides to keep the equation balanced. Next, we want to isolate our term that contains x, so we can add 5 to cancel out the -5. Since NumWorks only has one minus key that also operates as a negative button, typing in -44 plus 5 will never give you a syntax error. And we get -39 equals -3x. We can then divide both sides by -3 to get x by itself. This gives us our result of x equals 13. Here is another example where the Equations app can help us get the solution, and it will even provide the simplest radical form automatically. Let's erase our previous equation and type in x squared plus 4x minus 3 equals 0. Selecting Solve will provide us with both solutions in simplest radical form. Here we can see that our solutions are -2 plus or minus the square root of 7. Let's examine where this answer comes from. Recall that the quadratic formula is x equals -b plus or minus the square root of the quantity b squared minus 4ac, all of that divided by 2a. This is also included on the Regents Examination reference sheet for Algebra 1, so you do not have to have this memorized. We can fill in these variables with the values a equals 1, b equals 4, and c equals -3. We can then simplify each term to arrive at -4 plus or minus the square root of 16 plus 12 all over 2. If needed, we can type in the square root of 16 plus 12 in the calculation app to get the simplest radical form for this term. This simplifies to 2 times the square root of 7. Since both numbers in the numerator are divisible by 2, let's simplify this to get our final answer of -2 plus or minus the square root of 7. For our final problem, we can again obtain the solution in the equations application, but we still need to know the steps to get the final answer. Typing in the equation x squared plus 8x equals 33 and selecting solve will provide us with the solutions of x equals -11 and x equals 3. Now that we know the correct solutions, let's focus on how to obtain these using the method of completing the square. Since we already have x squared plus 8x on a side by itself, we need to calculate the quantity b divided by 2 squared, where b is the coefficient in front of x. And then we will add that to both sides. We can plug this in on the calculation app with the number 8 divided by 2 and then square this to see that that is going to be equal to 16. This means we will have x squared plus 8x equals 33, and we will add 16 to both sides. 33 plus 16 is 49. Since we're completing the square, this one is going to be an easier one to factor because we will just take the square root of 16, which is 4, and we will have x plus 4 squared equals 49. Now we can take the square root of both sides, but note that taking a square root in an equation means that we could now have a positive or a -7. This gives us two different equations, x plus 4 equals 7 and x plus 4 equals -7. We could subtract 4 to get x equals 3, and we could subtract 4 to get x equals -11. This means our solution set is x equals -11 and 3. Thank you for watching the Making the Most of NumWorks for the Algebra 1 Regents webinar. I hope you have enjoyed learning more about how NumWorks can help improve performance and understanding of Algebra 1 content for the New York's Regents Examination. If you have any questions, please feel free to reach out to us at contact@numworks.com.